Hello students, in this section, section 10.2, we will discuss the chi-square independence test. So before we look at some problems in the homework, let's go ahead and go over some background information. We use the methods of this section to determine whether a relationship exists between two qualitative or categorical variables. The data we will work with in this section will usually be summarized in a table called a contingency table. So the categories of one variable will be listed at the top, which are the columns of the table, while the categories of the other variable will be listed on the left-hand side, which are the rows of the table. So this is why the variable whose categories are on the top is called the column variable, and then the variable whose categories are on the left side is called the row variable. The numbers you see in a contingency table are called the observed frequencies, which represent the number of individuals in our sample that belong to each cell in the table. The cells of the table occur where the category of one variable intersects with the category of the other variable. The number in each cell is sometimes called the joint frequency. Okay, so for example, we see on page 538, a researcher wants to determine whether a relationship exists between where people work, whether they work at the workplace or at home, and their educational attainment. Okay, so those are an example of two categorical variables. And it says that the results of a random sample of 925 employed persons are shown in the table. And it says that the source of this data comes from the U.S. Bureau of Labor Statistics. Okay, so here we have an example of a contingency table. So on the top of the table, we have the variable where each person works. And the two categories are either they work in the workplace or they work at home. So where they work would be considered the column variable, since the categories of this variable form the columns of the table. Okay, and then likewise, educational attainment is the row variable because the categories are listed in each row, and then these are the different categories for educational attainment. And then the numbers you see in each table represent the observed frequencies, and they tell you how many people in our sample fall into each cell of the table. Okay, let's go to move on here. So the null or alternative hypotheses for the problems in this section will be some variation of the following statements. So the null hypothesis will be that the two variables are independent, and the alternative hypothesis will be that the two variables are not independent. So when two variables are independent, that means there is no relationship between the two variables. So in other words, the outcome of one variable has no effect on the outcome of the other variable. So on the other hand, when two variables are not independent, that means that there is a relationship between the two variables. So in other words, the outcome of one variable does affect the outcome of the other variable. The hypothesis tests in this section are always right-tailed tests. So this means that the rejection region of the test will be in the right tail of the relevant probability distribution. So in other words, the rejection region can be written mathematically as follows. So since the rejection region will always be in the right tail, right, your answer choice for the rejection region will always be will always look like this, right? So chi-square is greater than chi-square sub 0, right, where this notation represents the critical value that you will get from using the chi-square calculator in stack. So in some of the problems, it will ask you for the degrees of freedom. So the degrees of freedom is equal to r minus 1 in parentheses multiplied by c minus 1, also in parentheses, where r is the number of categories of the row variable, and then c is the number of categories of the column variable. Okay, so let's go ahead and take a look at our first problem, which will be question 3 in the homework for section 10.2. And the problem says the contingency table shows the results of a random sample of former smokers by the number of times they tried to quit. smoking before they were habit-free and gender. So in other words, the two variables are, okay, the number of times they tried to quit, and then the gender of the individual. And you can see that they categorize the number of times the person tried to quit as either they quit after one time of trying, or they quit after 2 to 3 times, or it took them 4 more times before they quit. So at alpha, which is the significance level, so at alpha equal to 0.05, can you conclude that the number of times they tried to quit before they were habit-free is related to gender? So we're going to perform the indicated chi-square independence test by completing parts A through E. Okay, so in other words, we want to know whether the gender of the individual influences the number of times that they tried to quit before they were habit-free from smoking. So in part A, we're asked to identify the claim and then state the null and alternative hypotheses. Okay, so in other words, remember the null hypothesis means that the two variables in question are independent. So for the null hypothesis, we're going to say that the number of times former smokers tried to quit, okay, is independent of gender. Okay, and then the alternative hypothesis will be that the number of times former smokers tried to quit is dependent on gender. Okay, so which one of these statements, the null hypothesis, okay, or the alternative hypothesis, represents the claim given in the problem? Okay, so when you read this statement here, right, can we conclude that the number of times they tried to quit before they were habit-free is related to gender? So remember, if two variables are related, it means they are not independent, meaning that they are dependent. So the claim here can be represented by the alternative hypothesis. Okay, so next we're asked to determine the degrees of freedom. So remember our formula from earlier, which says that the degrees of freedom is equal to r minus 1 in parentheses multiplied by c minus 1 in parentheses. Okay, so looking at our table here, we can see that there are 1, 2 categories for the row variable. Okay, so r is equal to 2, and then 1, 2, 3 categories for the column variable. So c is equal to 3. Okay. Okay, so we can write this out, okay, using this formula. So remember, r is equal to 2, c is equal to 3. So basically our degrees of freedom is equal to 2 minus 1 in parentheses multiplied by 3 minus 1 also in parentheses. So when you use the order of operations, right, make sure you do the subtractions in parentheses first. Okay, and then multiply. So 2 minus 1 is 1, 3 minus 1 is 2. And then once we do the subtractions, we can remove the parentheses. So 1 times 2 is 2. Okay, so there are 2 degrees of freedom for this problem. So df is equal to 2. Okay, so now we're asked to find the critical value for this problem. Okay, so this is where we will go to StatCrunch. Okay, so what we're going to do is go to Stats, Calculators. So because the hypothesis test we're doing is called the chi-square independence test, we're going to use the chi-square calculator to get the critical value. And remember, these types of tests are always right-tailed tests. So make sure standard is selected. And we're going to select the greater than or equal to symbol because it's a right-tailed test. And we're going to type in the degrees of freedom here, which is 2. Alright, and then our significance level goes in this box. Okay, and the problem says, so it says our significance level alpha is equal to 0.05. Which will go here. Alright, and then when we click compute, you can see that the right tail of this graph is shaded. Okay, so we're going to go ahead and type in the critical value, and we're going to round that to 3 decimal places, so it's 5.991. There's our critical value. Okay, then it's going to ask you to identify the rejection region mathematically. Okay, so remember in our notes we said that the rejection region is represented by this, right? So chi-square, which is our test statistic, is greater than the critical value that we just got. Okay, so if our test statistic represented by chi-square is greater than the critical value, we'll end up rejecting the null hypothesis. But if not, we do not reject the null hypothesis. But in any case, to answer this part of the question, right, select this answer choice, and then the one that looks like this. Okay, and then we're going to calculate the test statistic. So to calculate the test statistic, we need to copy the table over into StatCrunch. So go ahead and click on this icon here, click to copy table, and I'll select copy to clipboard, and then hit Command C or Control C on the keyboard to copy that data. And then head on over to StatCrunch. Go ahead and close this window. Alright, and at the very top row here, right, it doesn't matter which column, right, very top, just click in it and then paste the table. Okay, so you can see that the categories of the column variable are listed at the very top. And then the row, the categories of the row variable are in the first two rows of the spreadsheet. Okay, so now what we do is we go to Stat, Tables, Contingency, and then since we have a summary of the data, we're going to select with Summary. Alright, and we're going to go ahead and select the columns except the gender, so do not select gender. Alright, we're going to select the columns that represent the categories of the categorical variable, so the number of times they quit before they were habit free. So gender just tells you so gender is one of the variables, right? So we're not going to include that as one of the columns. Okay, and then the row labels are listed in the gender column. Okay, so that's why we don't select gender. Alright, and then the hypothesis test we're doing is the chi-square test for independence, so make sure that's selected. And then we can leave everything else alone, hit compute. Okay, what we want is that test statistic. Okay, so we're going to go ahead and round that to 3 decimal places, so it's 0.012, so that 1 at the end gets rounded up to a 2. 0.012. Okay, and based on that test statistic, we're going to decide whether we will reject or fail to reject the null hypothesis. Okay, so we simply compare it to our critical value from earlier. Because remember, we only reject the null hypothesis if our test statistic, okay, is larger than the critical value, and that's always the case for these problems. Okay, so we can see that our test statistic, which is 0.012, is clearly smaller than our critical value. Okay, so in that case, we're going to fail to reject the null hypothesis. Okay, and then the very last part of the question says to interpret the decision in the context of the original claim. Okay, so because we're failing to reject the null hypothesis, okay, and the claim of the problem is represented by the alternative hypothesis. So what that means is that there is not enough evidence at the 5% level of significance to conclude that the number of times former smokers tried to quit, right, is dependent. Okay, and the problem says specifically, the claim says specifically related, but remember the word related means dependent. So if two things are related, it means that one thing is dependent on the other. So that's why we select is dependent on gender. So in other words, there is not enough evidence at the level of significance to conclude that the number of times former smokers tried to quit is dependent on gender. So basically what we're saying is that there's no relationship between the number of times a former smoker tried to quit and then the gender of the smoker. Okay, and that completes question 3 and 10.2.